For most of the people who joined cybersecurity industry after 2015, rootkits and bootkits more like a stories from the book or history. But between 2005 and 2010, it was indeed an age of really fast and exciting Windows NT kernel exploration. As of today, I consider Windows kernel is very well explored and very well documented, and you can find a lot of information about it and how it works, and what kind of internals it consists of. But back then, the best source of information you would get would be a Windows internals book from David Solomon and Mark Rusinovich. It was really not that much explored. The rootkits were really a new thing, and they were evolving very quickly, and it was kind of a golden edge of rootkits, if you want. And today we're going to talk about what rootkits are and how do they work. But first, let me clarify what was the main goal of the rootkits, because from the name rootkit, it's really confusing because the name came from Linux world from 90s, what the rootkit would mean to get root privileges, install the kit which has access to whatever it wants. While in the era of Windows malware, the rootkit changed the meaning. And really what rootkit means most of the time, in most of the discussion when we're talking about Windows malware, or malware in general, it's a component which has a main goal to hide malware. The rest of the payload, the rest of the malicious operation on the computer, on the system, the main goal of the rootkit is hide malware. So the question is, of course, hide from who and hide what, right? And most of you would say, well, of course, it's hide from antivirus. Well, it's not that simple, because it can also try to simply hide its behavior from user. Because in period of 2005-2010, not by far, not everyone would have an antivirus. In a lot of cases, to discover malware, user would need to spot something fishy is going on. Sometimes malware would just to try to hide its behavior from a user rather than from any anti-malware systems. And of course, the second who would be antivirus. And the methods and techniques of hiding from a user and hiding from antivirus are slightly different. Of course, from user to hide from user, you only would need to hide from pretty much two applications: it's Explorer and Task Manager. If malware is able to hide from Explorer and Task Manager in 2005-2010, it pretty much means the user cannot detect it. There were not that many other tools like sys monitor, process monitor. Of course, they were developed, but they mostly were used by very advanced users who could interpret these results. And most of the other users, the maximum what they could spot is suspicious files on the file system or the suspicious processes or network activity. And of course, more sophisticated rootkits would try to hide malware from antivirus engines. But what exactly they would try to hide? Of course, files on the file systems. It's a registry keys, specifically autorun keys, and autorun the hundreds of different ways to set up itself in autorun, and malware could potentially use any of them. And of course, the rootkit would hide it from the antivirus, so antivirus could not spot it and clean it up. Processes and network. These four would be the top artifacts the rootkit would try to hide from antivirus and also from user to prevent malware detection on the system. To understand how rootkit hide malware from either user or anti-malware software, you first need to understand how anti-malware software or the user would actually see the malware. And we already discussed to see malware, it means see the file or process or network connection, or in some cases the registry key. This is very simplified architecture of how Windows operating systems in general work. Very, very simplified. But if you have a user application or a service process, and in this case, let's simplify it again, User application would include a task manager or explorer. It can also include antivirus, so antivirus also can be a service process, right? In any case, if three of these things trying to know something about the operating system, including file, registry key, network connection, how do they do it? They would call API functions, and they would call API functions to subsystem DLLs. You might heard a lot kernel 32 DLL or lower level NT DLL, and they would call create file or get registry key or open the network connection or something like this, right? They would interact with the operating system using these APIs. And APIs are implemented through the subsystem DLLs, which by themselves are executable files, and they actually implementing the functionality needed to execute this system request to read the file or get access to the process. And they're running in user mode, right? But not everything implemented in user mode by far. And so those calls, if they cannot fully execute everything needed to return the results, they actually execute syscalls. It's a system calls into kernel memory, where then kernel implements, for example, access to NTFS file system, or for example, network TCP IP stack, or list of processes, and then the results are returned back and back. That means if you're implementing the rootkit, you actually have multiple places where you can intervene with this process of API calls and fake the return results. For example, you can intervene on a level of API call. You can do something with the user mode DLLs. You can actually modify the kernel itself. Very often when people talk about rootkits, they're like, oh, it's a kernel drivers doing the. But in reality, the rootkit is trying to hide malware, and there's a lot of opportunities to do it depending on what actual goal is. And so on the next slide, what we're going to talk about of how malware actually implements those different opportunities. And as you noticed, of course, there is a user mod and there's a kernel mod. So the rootkits could be a user mod rootkit or kernel mod rootkit, depending on what level it's actually implementing its rootkit functionality.